Good day, grade 12s. Here today we are going to do calculus, specifically derivatives. Okay, so derivatives are an extension of the idea of gradients. Last year, as well as in grade 10, you were introduced to average gradient, where you were only limited to gradients of a straight line. But now we can extend the idea of gradient at a point for other functions like parabolas, hyperbolas, exponential function, cubics, as well as other functions. Okay, so now we are just saying you are able to calculate the gradient of the other functions other than the straight line function. For a straight line function, the gradient that we would usually be able to find is the average gradient, which is given by this formula here. M equals to y2 minus y1 over x2 minus x1, and this would give us the gradient of any straight line. Okay, if we are using 2 points that are collinear. All right, and then now, as I've explained, when we deal with derivation, we are simply finding the gradient of a function, any function. Okay, not now only limited to straight lines, but we can be able to find the gradient at any point for any particular function. And also, when we are deriving, which you will see later on, especially for a parabola, when we are deriving a parabola, then the derivative of a parabola gives us the equation of a straight line, and we sometimes call that equation the equation of a tangent line to the parabola. A tangent is a line that touches a parabola at only one point. Okay, so when we take the derivative of a parabola, we get the equation of a tangent line to the parabola. And then we will come back to the question 7. We have a few notes that I want us to go through before we can start answering question 7, so that at least when we start with question 7, we have an idea of what is it that we are expected to know. Okay, now I've already explained that deriving or derivation is there to help us find the gradients of other functions as well, other than just a straight line. Okay, so with derivatives we have what we call notations. Okay, so these notations are different symbols or different representation as to how a derivative may be represented. Now we've got 5 of them, and we'll take you through each one at a time. Now, number 1, let's say I'm given a function f of x, as we would normally give you in functions, and then I say to you, find f prime of x. Okay, so that apostrophe there stands for prime, and f prime of x is what we call the derivative of f. So the first notation is written like that. Please note the difference between the given f of x and the f prime of x. So when you write f prime of x, you are saying it's a derivative of f. Okay. Then secondly, I may give you an equation in this form, y equals to something, and then I say find a y prime. So the y prime at x will be the derivative of the y equation which will be given to you. Okay, that's a second representation. Thirdly, I still give you y equals to something, which will be an equation. Then I say find dy over dx. So this is a third representation, or how we can represent the derivative of that equation. Okay, with this notation or symbol, what is important is check the variables at the top and at the bottom. At the top we've got y, at the bottom we've got x. So what is the meaning? The meaning is the top variable always says make me the subject of the formula. Okay, and then the bottom variable, in this case x, says make derive this variable, derive x. So in a way, what I'm saying is, let's say I've got dm over dn. Okay, so from the given equation, you will have to make m the subject of the formula and then derive the variable n. Okay, this is very, very important because sometimes the equation may not be given in a standard form, and that's where you need to start. First, make one of the variable a subject of formula and then derive the other variable. Okay, then the fourth notation that we have here, if I give you an equation in the form of f of x equals to something, then I may say to you, find d over dx f of x. Okay, look at the difference between the third and the fourth notation. With the third notation, you say dy over dx. That's when you're deriving, then you say equals to, you write your answer after deriving. Okay, but that is not the same with the fourth notation. With the fourth notation, you say d over dx, then the d over dx and the f of x, they go together in one. Okay, so this is like a single entity, they go together. The equals to only comes after the f of x. Okay, very, very important. So in brackets, that means you'll be putting the equation which is given to you, or the equation that you are deriving. Fifth notation, say I'm giving you f of x equals to, now f equals to whatever that will be given to you. Then I say to you, find dx f of x. Okay, so the fourth and the fifth notation, they are more or less the same because both of them, you only put the equal to signs after the f of x. Okay, so the f of x and the notations, they move together. So that will be d over dx f of x equals to, you write your answer after deriving the given function. Then even here, it's dx f of x, then you write equals to after deriving. Okay, where now you will drop the dx in this case. Okay, so it means when you're deriving, you no longer write dx, this one, now you write your derivative. And then also in this case, immediately you are deriving, you no longer write d over dx f of x, but now you write your answer, which is your derivative. Another thing that I want you to notice is, as we are having d over dx, what is the meaning here? I'm still deriving that variable in the denominator. Okay, very, very important. So it means I can say to you, find d over dy f of x. So you'll be deriving y. Okay, so you always derive the bottom variable. Same applies to here. I'm deriving x. So it means I can say to you dm f at m. Okay, so what does it mean? It means I'll be deriving the variable m and not x, because I won't be having any x there. Okay, so you derive the variables that I've shown to you. So these are the 5 notations that we have when we are dealing with derivatives, and you need to know them. These are 5 different ways in which we can represent a derivative. Okay, remember, a derivative gives you the equation of a tangent line to a function, but immediately you put in a particular x value, then you're saying you want to know the gradient at the point x equals to 2. All right, now there is what we call the power rule, very important. That is the method that we use to find the derivatives. So what does the power rule say? The derive f of x. So what did we say about the power rule? The power rule says drop the exponent to multiply the number in front there, which is 1. So 2 times 1 is 2, and then from the exponent 2, you need to subtract a 1 like I've done there, and then we know that we'll be left with a 1. 2 minus 1 is 1, so it means the final answer of the derivative of f is 2x. Okay, but look at what is written here. This is not f of x, it is f prime of x. If that prime is not there, then the whole thing is incorrect, because we need to know that this is a derivative. Okay, let's look at another example and see whether you understand what we are saying. Now we are given f of x equals to 1 over 3x squared plus 1. So we need to find the derivative of f. So what did the power rule say? You drop the 2 in here in front to multiply with the number that is already there in front. So 2 times 1 over 3 is 2 over 3, like I've done there. And then minus a 1, we are left with an x. Now, what is the derivative of a constant? Please note it down. The derivative of any constant, a constant is a number without a letter next to it or attached to it. So, the derivative of a constant is 0. Okay, that's why I wrote 0. But in the final step, I don't have the plus 0 because the additive property of 0 is that if you add any number to 0, the answer will be that number. Okay, so the answer, the derivative of f is equals to 2 over 3x. Okay, using the power rule. And then let us go to the next example. We are given y equals to 1 over 4x cubed, and you must find the derivative. So now I want us to use the first notation that we looked at. The third notation, I'm not sure, but then I want us to use this notation. How do we find the derivative of y? Remember, using the power rule, we drop the 3 to multiply with the 1 over 4, and the answer is 3 over 4. Then subtract the 1, we are left with a squared. So the answer is derivative of y equals to 3 over 4x squared. Okay, then let's go to the next one. Y equals to minus 2x cubed plus x, and I want us to use the same notation again. Y prime, or the derivative of y, is equals to, we drop the 3 to multiply with the minus 2, and the answer is minus 6. Then minus a 1, we are left with a 2. Okay, and then remember, if I have a plus x, on the x exponent is 1. We usually don't show it, but there is a 1. So when I drop the 1 to multiply with a 1 in front here, I get a 1, of which I didn't indicate, and then subtract a 1 on the exponent, so it will be 1 minus 1, which is 0. Then x to the power of 0 is 1, so it's like 1 times 1, and the answer being 1. Okay, very, very important. And then now lastly, let us look at the next sum. We have y equals to minus 4 plus 2x squared. Okay, we need to find the derivative of y. So how do I find the derivative of y? Remember, first of all, the derivative of a constant minus 4 is 0. So usually I don't write the 0, but there is a 0 there. And then plus. Now how do I differentiate 2x squared? How do I derive that? I drop the exponent to multiply with the 2 that is already in front there, and then I subtract a 1 on the exponent. So 2 times 2 being a 4, and then 2 minus 1 being a 1. So we end up with 4x to the power of 1, but I don't usually show the 1. Okay, very good. Now let's look at the other ways of representing the derivative. If I'm given y equals to minus 2x squared, and I say to you, find dy over dx, what do we remember? Y must be the subject, x must be the one that we derive, okay? The one that we perform operation on. So, is y the subject of the formula already? Yes. And then let's derive. So we drop the 2 to multiply with the minus 2, we get a minus 4. Then subtract a 1, then we get a 1, and therefore x is to the power of 1. But the final answer will be dy over dx. So immediately I write dy over dx, I'm deriving. Okay. Don't write dy over dx, then you say minus 2x squared. That will be incorrect. Immediately write dy over dx, then my derivative. Well done. Let's go to the next one. We want to find dy over dx, but we are given the equation y equals to half found the derivative. We actually, the same equation just with in an extended form. So y equals to half x squared plus 2. And then when I derive this is dy over dx, y must be the subject of the formula x is 1 over x. So now is that happening? Y is the subject of the formula. Then now I'm deriving. So I'm going to use the 2 to multiply with the half. Half times 2 is 1. Then subtract the 1 on the x-axis. Like 1x to the power half. Then concept is 0. So they are substituting like 0. But remember, 0 is a 0. So we don't need to solve the problem. Right? Now let's go to another example. I'm given now this equation here. This is not in the form. And then substitute the distance dy over dx. This is now what we can say. Simplify dy over dx, meaning y is equal to x plus 1. So if you the first thing that I need to do is change y from x to a minus on the x-square. So the first exponent is 4 times x plus 0. Then the second exponent is that y is equal to minus half x squared. Okay, this one the subject of the formula x is 2. Then dy over dx is not the 2 times the minus. Minus 1 so 1 to minus 1 is 1. Then what is the maximum of x squared? Is 1 plus 1. 1 plus 1 is 2. X plus 1 is 0. F of 0 is 1. So that means of 0 is minus plus. Please note that there's a different thing. The top variable dy, meaning y is the subject of the formula, and then the bottom variable is the one that is derived. Now let's come to this one. I'm given here 2y squared plus x squared plus 1. Okay, this is the top formula. Now take the log of dy over dx is the opposite. So what does it mean? It means with x, the subject of the formula, to derive the exponential derivative that I'm going to do is to simplify x with x, the subject of the formula. So the subject is x. Now, let us do this. How are we going to make x equal to x? Transpose the 2y squared to the right hand side, and we are getting minus 2y squared plus the one that was already in there. Now I have x equal to then dx over dy, I'm happy, meaning now I'm deriving the variable y. So minus 2 times 2 is a minus 4. Subtract the 1 on the exponent is 1. Okay, then the derivative of a constant is 0. So the final answer is minus 4y. Okay, now next up we want to look at this example. There is a rule that says if you have a variable in the denominator, make sure you move it from there. Okay, the variable must not be in the denominator. So just say the bottom, I wrote something. If you have 1 over x to the power of n, then there's a variable in the bottom. Make sure you move it. How do you move it? 1 over x to an exponent is the same as x to the power negative that is exponent. Okay, now let's try and see if we can apply that in this problem. I've got y equals to 2 over x squared plus 2x. Okay, now remember the 2 plus the 2, but what will be 1 over x squared? That will be x squared minus 2. So this part here, 2 over x squared is 2x plus minus 2. Then minus the reciprocal side of 1 over x squared. Okay, so x to the power minus 2 is 1 over x squared. And then plus minus 2. Now I'm going to derive. Then I'm finding dy over dx. So is y the subject? Yes. Am I deriving x? Yes.
gonna drop the minus 6 multiply with the 2, getting a minus 4, then subtract the 1. So when I subtract the 1, it becomes a minus 4. Okay. And then here there's a 1, drop the 1 to multiply with the 2, then minus the 1. X to the power of 0 is 1, 2 times 1 is 2. So the final answer is minus 4x to the power minus 3 plus 2. It's not a must to always write your exponents as positive exponents, okay, unless you are told to do so. So this step is not necessary unless you are told to write your exponents as positive unless you are told to write your answer in all the equations. So x to the power of minus half, the minus, and then the 1 over, okay, 1 over the same base x to the power now positive exponent. Okay, well done. Now, also, if I'm given a square binomial, you must first, I wrote it down there, you must first expand. Okay, so the first thing that we are going to do is first expand. So how do you expand the square binomial? Obviously, you can open two brackets and then the product. So my answer then becomes x squared plus 4x plus 4, which is 3 complete.
So you need to know that there is a 0, okay?
Now, next up, we want to look at this part here. Wow, it's a nice one. And what we have, we've got y equals to x plus 1 over x squared with x plus square root x. I'm not happy with the step x. Okay, so I must change this. And before I change this, I also notice that I've got two terms in the denominator, which means take out the common factor. So what is common there is my square root x. So root x into x root x, I'm left with x. And then root x into root x plus 1. Okay, then the x plus 1 cancels, and I'm left with nothing at the top, which is just 1, then all over root x. Okay, and then now remember I said to you, you must show me what is root x. X is x to the power of 1 over x. Then 1 over x to the power of half, written as x to the power minus half. Okay. The 1 over is your minus the same exponent.
And now, are you ready to derive? Yes. If I'm finding dy over dx, y is the subject of the formula, and I'm deriving x. So I drop the minus half to multiply with the 1 here. I get a minus half. Then I subtract the 1 on the minus half. I get minus 3 over 2. Remember, it's not a must to come to this step here. Okay, to come to this step here, unless you're told to write in positive exponents. So this will be minus 1 all over 2x to the power
x minus 0 over 2. Okay. Now this, remember, becomes a 1 over x to the power 2 over 2, and then multiplies with 2, and we end up with that answer. Okay. And then now, next up, we want to look at the fourth notation, which is d over dx. Remember, I'm going to derive x, meaning I still need to make y the subject. So, am I happy with the equation? Yes. Don't need to simplify first. So y equals to minus 3x to the power minus 2 plus x. So I'm going to drop the minus 2, and I get minus 3 times minus 2 is 6. Then subtract the 1, I end up with a minus 3. Then plus x, when I derive plus x, the answer is 1, because the x had a 1. So drop 1 times 1 is 1. Then minus a 1 on the exponent is 0. X to the power of 0 is 1. Hence we end up with 1. You are not it's not a must to end up to this step here unless you are told to write your answers in a positive exponent. So x to the power minus 3 is the same as 1 over x to the power of 3. So 1 over x to the power of 3 times 6 is 6 over x cubed. And then this is plus 1. And that is the answer. Then I'm here now. Next example, f of x equals to 4 over 3 square root x. I'm not happy with the square root x, so I first need to make sure that this is written in a appropriate way. Okay, so this can be 4 over 3, all multiplied by 1 over x square root x. And then I know that square root x is the same as x to the power of half, but since it's a 1 over x to the power of half, this is x to the power minus half. Then I derive now, meaning I drop the minus 1 over 2 in front, multiply with over 3, and my answer is minus 2 over 3. Then subtracting a 1, I end up with minus 3 over. Please note, if you are using d over dx to write the function next to d over dx inside bracket. Okay, don't forget. And then next up, I've already said this. F of x is written as a single notation with d over dx. Okay, don't say d over dx equals to whatever. So we write it as a single thing. And then also in this case, if you have d over dx, you have derived x. Then if you have d over dy, then you have derived so the other variable will be. Okay. And then next up, you want to look at the last notation. Remember, capital letter G subscript x, which is dx. Inside bracket, we have the given function. So I'm given y equals to 2 over 3 x to the power minus 1. So that's what I wrote in this. And then how I derive. Immediately I derive, remember I said you must drop the difference. Okay, so this will be minus 1 multiplying with the 2 over 3. And I get minus 2 over 3. Then subtracting a 1 on the exponent, I get a minus 2. You can stop here. Unless you are told to write your answers in a positive exponent, then it will be minus 2 over 3. Remember, x to the power minus 2 is 1 over x squared. So minus 2 times 1 is minus 2. Then 3 times x squared is 2 x squared. So the final answer will be 0. Now next up, I've got f of x equals to 2 over 3 x to the power minus 2 over 3. So remember, this can be written as 2 over 3 multiplied by 1 over x to the power minus 2 over 3. So the 1 over represents a negative. So it means the negative in the exponent here, and the negative from 1 over will be positive. And we have now 2 over 3 times x to the power 2 over 3. So now, how do I find the derivative?
Using the fifth notation, dx means put the function next to dx and then start deriving. Okay, so here I haven't derived. I was just writing it in this manner. And then now, next up, it will be dropping the 2 over 3 to multiply with the 2 over 3, and I'm getting 4 over 9. Then subtract a 1, then I'll be getting minus 1 over 3 on the exponent. So you can leave your answer there, or you can write in positive exponents, meaning this will be 4 over 9 multiplied by 1 over x to the power 1 over 3, which will be 4 over 9 x 1 over 3. Okay, very important. And then now also please read down there on the note. I think I've already emphasized this. Drop dx when you derive. All other derivation rules apply. That is our power rule. Okay, now next up we want to look at the second way of deriving. Remember, all examples that we have covered now, we were looking at the power rule, but we have another rule that we can use, or another principle that we can use to derive any function. Okay, and we call this the first principle. So the first principle is another way of finding a derivative, and this is the first principle formula. Okay, so when I say find the derivative of f using first principle, then you need to know that I'm saying use this formula. And this is the particular formula that we must use when we talk about first principle. Okay, so the formula says f prime of x equals to the limit as h approaches 0 of f of x plus h minus f of x all over h. Remember, this part here represents the average gradient. Okay, so we are looking at the limit as h approaches 0 of the average gradient of the particular function. Okay, and this gives us its derivative. Another thing, you're going to write the limit as h approaches 0 until to the last step, where you'll be substituting h as 0. We're not really saying h will be 0, but we are saying as h approaches 0. Okay, that is the limit. But we really gonna put a 0 in, which is not a problem. And then let us look at the first example. Find the derivative of f. Okay, that's the first thing. And then after finding the derivative of f, what do? You're going to substitute x equals to 3. Meaning when it's x, you're going to put it to 3. So it means you first find the derivative of f, and then once you have f prime of x, then you're going to put it away the x, meaning now I'll be finding the gradient at the point 2. Okay, so this is the given equation here, which is f of x equals to x minus 1 over 2 all squared minus 25 over 4. So that is the given equation. Remember I said to you, if you've got a four binomial like this one, you must first expand. So from my expansion, this is what I have. Okay, x squared minus x minus 2. I didn't derive, I didn't steal your f from this. But what I'm saying is, after you have expanded from this, then you will end up with square minus x. And then the next thing is that this is the first principle, then the so in the formula, I noticed that I have f of x plus 8, and I need to substitute x plus 8. Don't leave it. Once you leave it, the whole thing is wrong. Okay. Now what is common there? It's h. So I take out h as the common factor, where h and h cancel, and then I notice that
After cancelling, the sum will simplify to this. I'm left with 2x plus h minus 1. Okay. Then what did I say? I said at this point in time, I need to substitute 0 where there is h. Okay. So 2x plus 0 minus 1, that is simply x minus 1. Take note, I'm no longer writing lim here. There is no lim as h approaches 0 because now I substituted 0 in place of h. Okay, so that's my final answer. Using the power rule, we would get the same answer, but remember, subtraction is different. If you say using power rule, or if you say using first principle, after finding my derivative, remember I was finding the derivative at x equals to 2. So I substitute in place of x 2. So in place of x is 2, and then 2 times 2 minus 1, the answer is 3. The derivative at x equals to 2 is 3. The gradient at the point x equals to 2 is 3. That's the gradient. Okay, very, very important. Now next up, I want you to notice something that I said at the beginning of this presentation. I said when we got a parabola and we are deriving a parabola, what are you getting? The equation of the tangent line, the equation of the straight line to the graph. So the derivative of f is the equation of the tangent line to f. Okay. So I've drawn some steps for you. Let's say f is our parabola, and then I'm deriving f. What do I end up with? Where there's my derivative, which is now that's good. Next up, I give you another example. My f of x is a parabola minus 2x squared. This is a simple graph. Then derivative will be, remember I'll drop the 2 and multiply the minus 4 and separate 1. Derivative will be a minus 4. Tangent, therefore my derivative will be a line or the red graph this, okay, which enters the tangent to the graph of f and the point x. Well done. Now let's go to question 7, which was given to us, and try to answer and see whether we have what we have given. So in 7.1 we are given f of x equals to x squared plus 2. That's a parabola. Okay. And we must find its derivative, which will be an equation of a straight line or a tangent line to f. And we are given a very strict instruction from first principle. We must use the first principle. Remember, in the first principle, there is that part that says f of x plus a. Start by finding this before you go to the formula, and then so that when you substitute this, you will get now. Having said that, f of x plus h meaning where is x now? 9. By substituting and point that line in the graph, which is g at 1. You remember they said it's equal to 5. So g at 1, wherever there is x now, I see a 1, but g at 1 itself is 5. Then our t is equal to 3. By the